Okay, so let's consider the case now of a mass hanging from two unequal length strings. And so this horizontal line here represents the ceiling, let's say, from which we are supporting the strings. And so the longer string goes from here to the mass. The mass has a weight pointed downwards like this, and then the shorter string goes from the mass up here. And so the angles now are not the same. The longer string has a smaller angle, and the shorter string has a larger angle with respect to the horizontal. Um, and so to get some intuition here as to what's actually going to happen without doing any calculation at all, um, let's, as I've done here, represent the weight with of the mass with a downward vector mg. Um, and then so after drawing this downward vector mg, what has to happen is the sum of the of the tension vector t1 along the long string length, t2 along the short string length, and w downwards, they have to add to 0. And so the first thing I'm going to do is I'm going to take this w vector and draw the negative of it pointing up like this. So I've just copied this, and this dashed upward vector is just minus w. And so t1 is going to point along string 1, t2 is going to point along string 2, and I to understand how long to draw each of these vectors. So T1 and T2 are going to have to sum to minus W, because in that case T1 plus T2 plus W is 0. Um, and so what I do here is I draw a so this green line is parallel to string 2 and hitting the tip of minus W. And this other green line is parallel to string 1 and hitting minus W. And this tells me how long to draw each one of the tension vectors. So I draw T1 to go from the mass to the beginning of this first green line, and T2 to be from M to the beginning of this second green line. Because in that case, T1 plus T2 will add to minus W. Okay, and then the next thing, of course, is to break T1 and T2 into X and Y components, and then to use our Newton number 2. Now, from the drawing, without doing any computation at all, you can see that the larger tension is going to be along the shorter string. Okay, and so we're going to see that when we do the math down below here. Okay, so let's move ahead now and do the quantitative part. This geometric part where we're doing an accurate force diagram is of great value. This is the coordinate system assumption I'm going to make, and then based on x to the right and y up, I'm going to write down a Newton number two in the x direction and a Newton number 2 in the y direction. And so Newton number 2 in the x direction is going to be minus T1 cosine theta 1. That would represent this, which is pointing in the next direction, in the negative direction. Make sure you understand why it's cosine theta 1. Plus T2 cosine theta 2. That represents this guy. So these two have to cancel each other. You can see in the picture that it's pretty fairly accurately drawn, and they do geometrically fairly well cancel each other. In the y direction, we have T1 sine theta 1. That would represent this upward, the vertical component of T1, plus T2 sine theta 2. That's this longish upward red vector, which represents the vertical component of T2, minus mg. Okay, that's this guy, has to be equal to 0. Now, I'm not going to show you the details. You can fairly easily figure this out on your own, though. We can now take these two equations. We can assume that we know what theta 1 and theta 2 and m are, and so we have two unknowns, two equations, two unknowns. One unknown is t1, the other unknown is t2, and so you can simply turn the algebra crank and deduce an expression for t1 and t2, and here they are. Interesting thing for us is that if you take the ratio using these two equations of t2 to t1, they both have the same denominators, and they both have a numerator mg times cosine theta 1 or mg times cosine theta 2. So if you take the ratio of the two, everything cancels except for cosine theta 1 up top and cosine theta 2 on the bottom. And so the ratio of the length of t2 to t1 is the ratio of cosine theta 1 to cosine theta 2. So if you look up here in the picture, theta 1 is the smaller angle, theta 2 is the larger angle, and for cosine, cosine is the opposite of sine, in that a small angle for cosine makes the cosine big, and a larger angle makes it small. And so the fact that theta 2 is bigger than theta 1 then guarantees that the numerator is bigger than the denominator, and that's bigger than 1. And so that's the unequal string case, string length case.